Hello again. So now we're going to be talking about R scripts. You're going to be doing a lot of scripting this semester, so this is going to be your best friend. So as I was saying before, one of the nice things about R is R is interactive. So you get a console and you can try commands. You can try commands, you can try commands, you can run a regression model, you can, and I do that when I'm developing homework for you. I go into the R console and it's interactive. So you know immediately if your commands are working, you get outputs right away, and you can analyze your output and you see if everything's working fine. However, once you've done like a dozen commands, whatever, and you want to be sure that you can repeat those, what you can do is you can go to the history in RStudio. We're going to talk about RStudio in just 1 second. Or you can just use the up arrow in the console, and that will bring the prior commands back one by one. And then you can copy and paste all those commands into a program that we call a script. And a script has an extension .r, capital R, okay? And what you do is you enter all your commands in that script, then you save it. So then when you need to run the commands again, you load the script, and then you run the commands. And it's really neat because in the R console, you type a command, you press enter, and the command runs. In an R script, you can go to any line on the script and you hit Control Enter, and that command will be immediately copied to the console and run for you. But more interestingly, you can highlight a whole bunch of commands, like 5 or 6 commands in a row, that will perform a sequence of things you want to do. And when you hit Control Enter, they will all be executed one at a time. So it's a nice, convenient feature to have those scripts because you can put all your work there. One thing I encourage you to do with script is to comment heavily. And in the live section for this class, and also in the lectures, in the recorded lectures, you will learn how to put comments in your code. So in an R script, you're going to write commands to do some statistical work, but you also want to put comments so you can remember what you did, or you can explain to your colleagues what your commands do, okay? So R is an object-oriented language, as I was explaining before. An R script is a batch of commands, and what you do when you work with R is you work with objects. And objects have, as I was explaining before, objects have methods and have properties. Methods are functions and programs that are embedded within the objects, and properties are data that are embedded within the object. So when you create an object, you can invoke functions within those objects. You can invoke little programs to do little calculations and stuff like that. Or you can also retrieve data that is contained in those objects. Think of an object as a container. An object is a container. The nice property about an object is that an object can generate other objects. So many times, for example, you may be using a regression model, which is done by the linear model function, and the linear model option creates an object, which is a linear model object. Now, if you want to create, for example, do collinearity statistics, you can feed that object into another function from another library, and you can get collinearity statistics from that, and that creates another object with different information. So once you get used to this idea of working with objects and creating objects and retrieving data from objects, everything becomes really, really crystal clear when you start working with R. In scripts, we have functions, and functions are a key to libraries. Libraries are chock full of functions. There are functions to do regression models, to do trees, to do rich regressions, to do ANOVA testing, to do all kinds of things. But you can also define your own functions. You can write scripts, you can create your own functions. So for example, you want to take these two values and square them and add them and take the square root of that and multiply that by another variable, and you're going to be doing that over and over and over again. So why repeat all the instructions over and over again in your code? What you do is you create a function, and then you invoke that function that will create will execute all those commands for you every time you need them. The scripts have program control, so you can write a batch of commands and they will execute one at a time. But sometimes we want certain commands to be repeated over and over and over again. For example, we may be feeding a regression model that it has a linear component, then we want to try a square model, then we want to try a cube model, and then we want to keep going up to the 10th polynomial. Well, I can run a little loop that I write one model, and it increases the power one by one, and I make this run 10 times. That's called a loop, and we're going to talk about that next week in the R lecture. But loops are very typical in programming. Loops is what we use when we want to, for example, if you want to do a computation in every row of your table, you can define what you want to do on the first row and then loop and do that for every row in the table, and the loop will run until you're done. We have also if statements are very typically used. If statement also breaks the flow of the execution of the program. So you have a stack of commands going sequentially, and then you go into an if statement. And the if statement says, if these conditions happen in the data, execute these few lines of code. And if they don't fit this criteria, execute these other lines in the code. That's called an if statement. It's called conditional branching in computer software programming. But they're very simple to implement in R, and you're going to learn how to do that next week. Okay, so again, packages need to be installed. You can install groups of packages that comprise a view, and then all the packages will be installed for you. And then one of the things that you need to understand when you work with R is that the different data and objects that you have in R have different data types. So we're going to talk about data types and object classes a little later in the semester. So everything you need for this class, it's contained in two scripts. The iTech621 script.R that is available to you for this class contains every single script that we're going to need in this class. Just so you know, the Introduction to Statistical Learning book, which I call the ISLR book, is a textbook we use for this class, comes with very good code to do a lot of statistical learning and a lot of predictive modeling. But it's not very well explained. It's just code. It's just code. Now, there are some video lectures that we have posted that has the lectures given by the book authors. So I encourage you to go and look at those lectures, because we have the PDFs with lecture slides by the actual textbook authors. But they also have video lectures. So if you're having some trouble with the material, sometimes hearing the authors explain what they wrote in the book might help. So I encourage you to do that. But the book authors have a wonderful website, and the website has a lot of R code, has a lot of data sets, and by the way, you can get a free book in PDF format from the book website. So I encourage you to go there and see if that works for you. In my case, I decided to get the Kindle version and pay the price for the book, because I want to be able to annotate and highlight and do all of that. But if you want to save the money, you can get a free PDF, and it works perfectly fine. So what I did is I took all the R code that the book authors provided, and I saved it with a file name called iTech621 scripts.R. And then I took that and I added a whole bunch of R code of my own that I've been using. There are some techniques that I explain in this class that are not covered in the book. All that R code, it's there. I created a code myself, or I may have borrowed code from popular websites. But for the most part, I wrote some of the code that you have in there. And the other thing I did with that script is that I put heavy comments. So this script has about 5,000 to 5,500 lines of code for you to process, and you may think that's a lot, but I tell you, more than half of that is information for you. It's comments, instructions, when to use it, how to use it, all of that. The R621 packages.R is what I did is I went through the entire script for the class, and I parse every single package that we use for this class, and I put those package installations commands in this iTech621 package.R. So when you start this class, you may want to go into the iTech621 packages and just go ahead and install every package for this class. Also, I put the library loading commands together for all the libraries that we have in these packages that have interesting data sets. Because one of the nice things about these packages, they all have data sets. And when you start working on the project for this class, you have to identify a data set to work in this class. And a good source for data sets is the actual packages. So if you go and load all the libraries that have these interesting packages, then you'll have all the data sets available for you to explore and analyze to see which ones you want to use. Okay, that's all I have on scripts. So now we're going to move on to the RStudio lecture. Thank you very much.